Hey everyone. This one is such a satisfying geometry problem. It looks like we don't have sufficient information at first, but once you see the structure, it's actually interesting. So here's what we have. We've got a quarter circle centered at point O. Inside it, there's a smaller circle tucked into the corner, tangent to both radii. And then there's this horizontal segment of length 12 drawn at just the right height so it touches the top of the inner circle and meets the arc of the big quarter circle. And the question asks us to find the area of the blue region. Now, before we do anything, pause the video. Try to figure out what matters here. What information is actually useful? Okay, let's walk through this. First, let's identify what we know. The inner circle has radius r. Now look at that horizontal segment of length 12. It sits at height 2r. Why? Because it's touching the top of the small circle. The center is at height r, so the top of the circle is at height 2r. Now here's the big idea. That horizontal segment, together with the vertical radius and the slanted line from the origin to the left endpoint, forms a right triangle. So we have a right triangle with vertical leg equal to 2r, horizontal leg equal to 12, hypotenuse equal to a, which is the radius of the big quarter circle. That means we can use the Pythagorean theorem. So we write a squared equals 2r squared plus 12 squared. That simplifies to a squared equals 4r squared plus 144. Now keep that in mind. We're not solving for r, we don't need to. That's important. Because what we actually want is the blue area. The blue region is the area of the quarter circle minus the area of the small circle. So the quarter circle area is pi a squared divided by 4. And the small circle area is pi r squared. So the area S equals pi a squared over 4 minus pi r squared. Factor out pi S equals pi times a squared over 4 minus r squared. Now here's the key simplification. Let's rewrite that expression in a clever way. A squared over 4 minus r squared is the same as a squared minus 4r squared, all divided by 4. And earlier we found that a squared minus 4r squared equals 144. So now we substitute that in S equals pi times 144 over 4. And that simplifies to 36 pi. That's it. The entire blue region has area 36 pi. And notice something really elegant. It doesn't depend on r at all. Any radius that satisfies the geometry gives the same final area. That's the kind of result that makes geometry so satisfying. If this clicked for you, go ahead and like the video. If you figured it out before I did the algebra, definitely comment below. And if you enjoy clean geometric arguments like this, subscribe so you don't miss the next one. All right, thanks for watching, and I'll see you in the next problem. And if you enjoy clean geometric arguments like this, subscribe so you don't miss the next one. All right, thanks for watching, and I'll see you in the next problem.